Okay, so for FRQ number 3, we have a 4 kilogram object and it is attached to a vertical rod by 2 strings, as shown in this figure right here. And the object rotates around this point in a horizontal circle at a constant speed of 6 meters per second. In this diagram, there's more information. We also know that the length of each string is 2 meters, and the distance between the string where on the rod is 3 meters. So part A wants us to draw the free body diagram of all the forces acting on this object. Okay, so here we go. So here's the rod. And here's a 2 string. Here's the object. Okay, so for any object there is of course Fg. So this object has Fg. We also have the forces of tension. So let's call this T1 here, T1. I'm only gonna point the arrow this way because we're focusing on this object. And there's T2 right here. And the arrow's pointing this way, pulling it towards the side. Now T1 and T2 has components. There's T1y and there's T1x right here. T1x. Same goes for T2. So this is T2x and this is T2y. I also know that T1, wait, this is T2x by the way. T1x and T2x mix FC, so basically these two combined make FC right here. And so that's all my forces. So to the side, now I'm going to define what each forces is. The question doesn't ask that, but it's more convenient to do it right now instead of doing it for other problems later. So T1x is, I'm putting relative to this angle right here. T1x is going to be equal to T1 sine of theta relative to this angle. Now T1y, this one right here is going to be equal to T1 cosine of theta. Similar case for T2, I'm doing it for the angle relative to the vertical. So T2x is T2 sine of theta. T2y is T2 cosine of theta. And Fg is just mg. And as I said before, Fc is equal to T1x plus T2x. So Fc is essentially equal to T1 sine of theta plus T2 sine of theta. Now we don't know what theta is, so here's another drawing that's going to help you find theta. So this is 2 meters right here, 2 meters and 3 meters. So I'm going to split this into 2 triangles. They're both going to be the same angles right here. So if I split it in half, this was 1.5 meters and this is 1.5 meters. To find theta is essentially equal to the arc cosine of this this line, this measurement over this measurement. So 1.52, and that's going to equal to 41.410 theta. Okay, so let's get started on our problem. So part B now wants us to find the tension of the upper string. So this tension over here. So to do that, I'm going to use Newton's second law, and examine the forces that are vertical. So the total force in the y direction is equal to m times ay. Now the ball is not moving in the vertical direction, so ay is 0 meters per second squared. And so that means my equation is, so the total force in the y direction, I have T1y, I have Fg, and I have T2y. Now these two forces are pointing out, and this force is pointing up. So T1y is going to be positive. This one's down, so T minus T2y minus Fg. And since my acceleration is 0 meters per second squared, this side is going to turn into 0. So now that I'm here, I'm going to plug in the forces I defined in terms of theta and T1, T2, into here, and mg. Okay, so T1y is T1 cosine of theta, T2y is T2 cosine of theta, Fg is mg, and this side is 0. So right now I can't directly solve for the T1 yet, the tension of the upper string, because there's two unknowns, T1 and T2. So what I'm going to have to do is I'm going to have to isolate for one of the variables, and then pair it with another, plug in another system, and to help me find my T1. So in this equation, I'm going to isolate for T2. So isolating for T2, I'm going to add T2 to the side. So I have T1 cosine of theta minus mg is equal to T2 cosine of theta. Then I divide cosine to the side, so essentially T2 is equal to T1 cosine of theta minus mg divided by cosine of theta. Okay, so now that I've defined my T2, now I'm going to use another system equation to help me find T1. Another relationship I know is centripetal acceleration. So I know that Fc is equal to mv squared over r. And I know that Fc I've defined up here is T1 sine of theta plus T2 sine of theta. And so this is going to be equal to mv squared over r. I'm going to plug in my T2 into all this in for T2. So T1 sine of theta plus all of this, T1 cosine theta minus mg divided by cosine of theta, and then times sine of theta is equal to mv squared over r. Okay, so now I'm going to distribute the sine and the cosine to the numbers in here, or the terms in here. So first of all, the first term stays the same, so T1's sine of theta. So distributing cosine cancels this cosine over here, and there's a sine over here, so the next term is going to be plus T1 sine of theta. Okay, so this have this is mg, and then sine of theta divided by cosine of theta is tan. So we also have mg tan of theta as my next term. Tan, and this is all equal to mv squared over r. These two terms are exactly alike, so I'm going to combine them to make 2t sine of theta. So 2t sine of theta. This is t1, by the way. Oops. 2t1 sine of theta. And I'm going to add mg tan theta to the side. So mv squared over r plus mg tan theta. Okay, so at this point I want to isolate for t1. So I divide 2 and divide sine theta over to the side. So essentially my t1 is going to be equal to mv squared over r plus mg tan theta divide by 2 and sine of theta. Alright, now I have to plug in all my numbers. Oh wait, I forgot to find r, so I'm going to do that right now. So r, I can find, this is r by the way, r I can I can find using Pythagorean theorem. So that's so hypotenuse squared is equal to the side square plus another side square. So r, we're isolating for r, I'm going to get r is equal to the square root of 2 squared minus 1.5 squared. And that means r is going to be equal to 1.323 meters. Okay, so now I'm ready to plug in all my numbers. So mass is 4 kilograms. My velocity is constant, speed of 6 meters per second. And then this is squared. Sorry. This is squared. My R, I've just found, is 1.323 meters. My mass, once again, is 4 kilograms. G is 9.8 meters per second squared. Tan of the angle is 41.410 degrees. And then for the denominator, I have 2 sine of angle is 41.410 degrees. Plug this whole mess into the calculator. We're going to get 108.419, and the unit is newtons for our tension of the upper string. Okay. Now part C asks us to find the tension of the lower string. So since we have the tension of the upper string, this is quite easy because we've already established a relationship between T1 and T2 up here, along with other terms. So I'm just going to use that. So as a reminder, the relationship I found is this. So T2 is equal to T1 cosine of theta minus mg divided by cosine of theta. Plug in my numbers. My T1 I just found to be 108.419 newtons. Cosine of 41.410 degrees. Mass is 4 kilograms. Gravity is 9.8 meters per second squared. All over cosine of 41.41 degrees is my theta. So plugging this into the calculator, we're going to get 56.152 newtons as my T2, which I use to represent my tension of the lower string. So this is the tension of the lower string. Okay. Now part D wants us to calculate the angular velocity of the object. This is quite easy. So the equation for angular velocity is velocity divided by the radius. So we just have to put in our numbers. So our velocity is 6 meters per second. Our radius was the radius of rotation is 1.323 meters. And then plugging this in the calculator, we're going to get 4.536, and the unit is rads per second, radians per second. Okay. Part E wants us to determine how much time it takes for the object to complete 10 revolutions. Okay, so E. So first of all, I'm going to use this kinematic equation, but with theta, with angular stuff. So this is theta is equal to omega initial plus times t plus 1/2 alpha times t squared. So this is similar to one of our kinematic equation that we know. Okay, so theta, so we have to determine 10 revs, right? 10 revs is equal to so 2 pi. So if we want to convert this to radians first. So we times by 2 pi rads over 1 rev. And so that means our theta is 62.832 radians. Our alpha is 0 rads per second squared because the object is rotating at a constant angular velocity. So now we just have to plug in our numbers. So 62.832 is our radians or theta. Omega I is 4.536 rads per second, and time is what we're trying to find. And all of this cancels out because alpha is 0. And so if we want to solve for time, we're going to divide 4.536 to this side. So what we get is t is equal to 13.853 seconds. Okay. This is seconds by the way. All right. For part F, we are asked to calculate the frequency of the object. Okay, so I looked it up, and frequency is equal to 1 divided by the period, which is represented with t. Now, a period is how long it takes to rotate 1 revolution. So t is equal to 1 rev divided by omega. So that is how long it's going to, that's the equation for period. And so 1 rev is equal to 2 pi radians, and alpha or omega is 4.536 rads per second. So plugging this in the calculator, we're going to get 1.385 seconds as our period. So now to find frequency, we plug in our numbers. 1 divided by our period, which is 1.385 seconds, And what we're going to get is 0.722, and our units is seconds to -1.